Hello everyone and welcome to another video. In this video we are going to do questions based on real numbers class 10th. We are going to do these 11 questions in this video. The LCM and HCF of two numbers are 101 and 7 respectively. How many such pairs are possible? A0, B1, C2, D7. So we are given LCM as 101 and HCF as 7, and we are going to consider X and Y as two such numbers. What we know that X and Y has HCF as 7. That means X and Y both are divisible by 7. So I can write X as 7 times A and Y as say 7 times B, where A and B are what? Coprime numbers. Now from the relation that is product of two number is equal to LCM multiplied by the HCF. So I'm replacing X here as with 7A and Y with 7B. That results to give you LCM, which is 1001 into HCF, that is 7. So 7 gets reduced here. So now I can write AB as what? AB as 1001, that divided by 7. It's divisible by 143. Now A and B, we have to choose two such prime numbers whose product is 143. So one possibility is 1 and 143, and the other such pair of a number whose product is 143. Clearly A and B are co-prime. So that is other possibility will be 11 and 13, right? So that write the HCF of the smallest composite number and the smallest prime number. A1, B2, C3, D4. The smallest composite number is what? 4, whose prime factorization is what? 2 raised to the power 2, and smallest prime number is 2. So if I have to find the HCF of 4 and 2, the highest common factor of 4 and 2 is what? 2. So we'll say that 2 is the correct answer in this case. Two numbers are in the ratio of 15:11. If their HCF is 13, then the numbers will be A 195 and 143, B 190 and 140, C 185 and 163, D 185 and 143. So let the required numbers be 15x and 11x. And why so? Because the numbers were given as 15:11. Now what you can observe that 15 and 11 are co-primes. Therefore, we can say that x is the highest common factor. That is HCF over here is what? X. And we were given HCF as how much? 13. So from here what we conclude that x is equal to 13. Now to get these numbers, first number is what? 15x, that is 15 times 13, and that is how much? 195. And the other number is 11x, that is 11 into 13, that results to give you 143. So we'll say that 195 and 143 are the two numbers. The product of two coprime numbers is 117. Their LCM should be A1, B117, C equal to their HCF, D lies between 100 and 110. The least number that is divisible by all the numbers from 1 to 10, both inclusive. A10, B100, C504, D2520. Factors of the number 1 to 10 are what? 1 can be written as 1 into 1. The factors of 2 is 2 and 1. Factors of 3 is 3 and 1. For 4 it is 2 and 2. 5 it is 1, 5. 6, 2, 3, 7, 1, 7, 8, 2 into 2 into 2, 9 as 3 into 3, and 10 as 2 into 5. Now for finding LCM, what do? We write down each prime with the highest times it occurs. So you can see 2 is occurring for maximum 3 times, 3 for 2 times, and 5 and 7 1 time each. So we'll say that in this case, the LCM of these numbers, that is from 1 to 10, is the product of these, which is 2520. If the HCF of 65 and 117 is expressible in the form of 65m minus 117, Then find the value of m. So by prime factorization, factors of 65 is what? 65 is can be written as 5 into 13 as its prime. And similarly, 117 is what? 9 into 13. So we can write 9 as what? 3 square into 13. Now check, we have to find the HCF, and clearly HCF is 13 in this case. So we got HCF in this case as how much? 13. Now, according to question, we were given, can we say that according to question, we can write 65m minus 117, which is the HCF, and that is equal to 13. Further, we can transpose 117 to the other side. That results to give you 13 plus 117 is how much? 130. And therefore, m is what? 130 divided by 65, that is equal to 2. So we'll say that m is 2 in this case. If LCM of 12 and 42 is 10m plus 4, the value of m is equal to A7, B8, C6, D9. Now, if I do the prime factorization of 12, it can be written as what? 2 into 2 into 3. And similarly, for the other number, that is 42, can be written as 2 into 3, 6 into 7, that is 42. Now, what is the LCM of this? You know that LCM will have the prime with the highest power. So I can see that 2 occurs for 2 times maximum. So 2 into 2, 3, 1 time, and 7 1 time. So 2 into 2, 4, 4 into 3 is how much? 12 into 7, 84. So LCM we got 84. Now what according to question, we can see that LCM is given as 10m plus 4, which I can equate with 84. So that results to give you 10m as how much? 80, or I can say m is equal to 80 divided by 10, that is 8. So we'll say the value of m is how much? 8 in this case. There are 24 peaches, 36 apricots, and 60 bananas, and they have to arranged in several rows in such a way that every rows contain the same number of fruits of only one type. What is the minimum number of rows required for this to happen? Now first we'll find the number of fruits in one row, which will be what? The HCF of 24, 36, and 60. Now for finding HCF, we are going to use prime factorization. So the first number is what? 24 peach. So it's 2 into 2 into 2, that is 8 into 3, 24. And for 36 is going to be what? 2 into 2, that is 4, 4 into 3 into 3, that is 36. And lastly for 60, it's going to be 2 into 30, 2 into 15, and 3 into 5. Now, for finding the HCF, we'll be looking for the common factor. I can see that 2 times is common and 3 1 time is common. So we can say that the HCF over here is what? 2 into 2 into 3. That results to give you how much? This is 12. So we got that we got the number of fruits in one row. Now check here. We have 24 fruits of one kind, right? 24 fruits of one kind. So if I have to arrange them in uh, with 12 with 12 fruits in one row, so the number of rows for this fruit will be what? 24 over 12. Similarly, for the other fruit, which is what here? 36 in number. So 36 divided by 12 will give you the number of rows for this fruit. And finally, it is 60 divided by 12. So give you the number of fruits of the kind third. Now, if I reduce it, what you can see that this is 12 one time, 12 two times, 12 three times, and 12 five times. So the final answer is going to be what? Will be sum of these, that is 2 plus 3 plus 5. That is equal to 10. So we'll say that there are 10 minimum number of rows is what we have to find out. So which is equal to 10 in this case. So what we know that LCM multiplied by HCF is equal to the product of two numbers. So as for the question, we are given LCM as how much? 45 into A. This is whole thing is LCM, and HCF is given as 13. And what are the two numbers? The two numbers are 65. So the product of two number will be 65 into 117. Later I can reduce it, says 13 one times, 13 5 times. So in order to get A, this is 5 multiplied by 117, that divided by 45. Now this can be reduced by 9 times. Further we can reduce 9, and 9 how much? 13 times, right? So we can say that A comes out to be how much? 13. So A is what we have to find out, and the value of A is 13 in this case. So what we should know that for a number in the form of P by Q, where P and Q are co-prime integers, and Q is not equal to 0, then the prime factorization of Q, if it is in the form of 2 raised to the power m into 5 raised to the power n, where m and n are non-negative integers, then it has terminating decimal expansion, else it is non-terminating. So let's begin with the first part over here. What we can see that it can be reduced, and I can see this is 7 11 times and 7 30 times. Now, if I find the prime factorization of 30, it is what? 2 into 3 into 5. So you can see that it has factor other than 2 and 3. So we'll say that it will have non-terminating repeating decimal expansion. Now, for the other part, you can see that it is in the reduced form, and the prime factorization of Q has factors other than 2 and 5. So again, it is non-terminating repeating decimal expansion. For the next, that is C part, what is it? You can see that this cannot be reduced further, and if I find the prime factorization of 3125, this is 5 raised to the power 5, right? Because 625 is 5 raised to the power 4. So you can see that I can write this as what? I can write this as 2 raised to the power 0 into 5 raised to the power 5. Now check here, I said m and n should be non-negative integer. So yes, we will say that this will have terminating decimal expansion. Let's see the last part also. You can see that the prime factorization of 17 is what? 17 into 1. It is not in the form of this. So we'll say that this also has a non-terminating repeating decimal expansion. So first we are going to reduce 51 over 1500. As you can see, they are not co-primes. In fact, divisible by 3. So 317 times, and this is 3 500 times. Now next I'm going to do the prime factorization of this number, that is 500. So this is 2 250 times. Further with 2 again, that is 125 times, with 5 25 times, 5 times, and 5 1 time. So what we can write this as, this is 17, and we can write 500 as a factor of 2 and 5. So this is 2 raised to the power 2 multiplied by 5 raised to the power 3. Now on comparing with m and n, we can realize that n should be equal to 2 and m should be equal to power of 5 is m, which is 3 in this case. Now since we have to get m plus n, that means m plus n is 2 plus 3. 2 plus 3, that results to give you 5 in this. So we will say that m plus n, which is 5, is the answer in this case. The number 4 raised to the power n, where n is a natural number, ends with a digit 0 for any natural number n. A true, B false, C can't say, D partially true or false. If the number 4 raised to the power n for any n were to end with a digit 0, then it would be divisible by 5 and 2. That is, the prime factorization of 4 raised to the power n would contain the prime 5 and 2.